Good morning, students. Yesterday we have already seen pseudo's first order reaction. So, once again, the definition of pseudo's first order reaction, the reaction in which molecularity of the reaction is more than 1, but the order of reaction is 1. It is known as pseudo's first order reaction, or the reaction in which one of the reactant present in large excess shows order different from actual order. It is known as pseudo's first order reaction. An example पाहिलेलं hydrolysis of methyl acetate. Methyl acetateचा hydrolysis using excess of water. Hydrolysis केल्यानंतर acetic acid आणि methyl alcohol तयार झालेलं. So in this reaction, the water is taken in large excess. The molecularity of reaction is 2, but the order of reaction is 1 because water is present in large excess, and that's why rate of reaction does not depend on concentration of water, and because of that the reaction is first order reaction. Now one more example of pseudo's first order reaction. The reaction is C12H22O11 plus H2O in excess gives C6H12O6 plus C6H12O6, that is glucose and fructose. Sucrose on hydrolysis using excess of water, it produces glucose along with fructose. So the molecularity of this reaction is 2. Molecularity of this reaction is 2, but the order of reaction is 1 because water is present in large excess and the rate of reaction does not depend on concentration of water. And therefore, the order of reaction is 1. So this is the second example of pseudo's first order reaction, that is hydrolysis of cane sugar to form glucose and fructose. Now next question, that is what is activation energy of reaction? What is activation energy of a reaction? Activation energy for the reaction to occur, the colliding reactant molecules must possess the minimum kinetic energy. So activation energy, it is defined as, for the reaction to occur, the colliding reactant molecules must possess the minimum kinetic energy, and this minimum kinetic energy is the activation energy. For any chemical reaction, the colliding molecules means reacting molecules. Colliding molecules means reacting molecules. These reacting molecules possess minimum kinetic energy. For the reaction to occur, the colliding reactant molecules must possess the minimum kinetic energy. This minimum kinetic energy is the activation energy. Okay. Next one, explain collision between reactant molecules. How the reaction is carried out. How the reactant reacts to form product. Collision between reactant molecules. Chemical reaction occurs as a result of collision between the reactant molecules. How chemical reaction take place? When reactants collides to form product and it undergoes chemical reaction. So therefore chemical reaction occurs as a result of collision between the reactant molecules. It is expected that the rate of reaction is equal to the rate of collision. It is expected that the rate of reaction is equal to the rate of collision. For gas phase reaction, when the reaction is take place in gas phase, for gas phase reaction, the number of collision is more and typically many powers of 10s compared to the observed rate. For gas phase reactions, the number of collisions is more and typically many powers of 10s compared to the observed rate. Okay, so this is reaction between reactant molecules. Now next question is Arrhenius equation. Write Arrhenius equation and explain the terms involved it. Very important question, Arrhenius equation. So Arrhenius equation is K is equal to A into e raised to minus EA upon RT. This is Arrhenius equation. Arrhenius equation, and we have to explain the term involved it. Arrhenius equation is K is equal to, K is rate constant, K is equal to A into e raised to minus EA upon RT, where K is rate constant. Where K is rate constant, A is, capital A is the pre-exponential factor. A is pre-exponential factor, EA is activation energy, R is the molar gas constant, and T is the temperature in Kelvin. Now one note is there, the pre-exponential factor, that is A, and rate constant, that is K, have same units. These two factors A and K have same units in case of the first order reaction. Besides, A is found to be related to frequency of collision. Besides, A is found to be related to frequency of collision, and the fraction of successful collision is given by the fraction of successful collision, it is given by F is equal to E raised to minus EA upon RT. This F is known as fraction of successful collision. Okay, for a gaseous reaction at 298 Kelvin, जर रिॲक्शन गॅस फेज मध्ये होत असेल, मग 298 केल्विनला ईची व्हॅल्यू किती, 75000 जूल पर मोल. For a gaseous reaction at 298 Kelvin, EA is equal to 75000 joule per mole. Therefore, F is equal to E raised to minus 75000 divided by 8.314 into 298 Kelvin. And that gives value exponential form पाहिल्यानंतर exponential of minus 25000 divided by 8.314 into 298 Kelvin. That gives correct answer 7 into 10 raised to minus 14. It gives F is equal to 7 into 10 raised to minus 14, or only 7 collisions in 10 raised to 14 collisions are sufficiently. Only 7 collisions in 10 raised to 14 collisions are sufficiently energetic to lead to the reaction. Okay, this is the note. ही नोट महत्त्वाची नाही, पण अरेनियस इक्वेशन महत्त्वाचं आहे. लक्षात, अरेनियस